Welcome back to Precalculus. This is the second portion of the video on section 5.3, solving trigonometric equations. We're going to pick back up at number 5. So remember that it's going to be just like solving algebraic equations. So I see a square in my equation. It's already set equal to 0, and I'm going to factor. If you have any trouble factoring, switch it first to 2x squared minus x minus 1 is equal to 0 and factor that, which would be 2x and x. The only choices here are 1 and 1. And if you make this one negative and this positive, the inners and the outers will make your negative x. So if you can do it with x's, then you can do it with sine of x's. Sine of x minus 1. Once I have my two factors, I set each one individually to be equal to 0. And I solve each one individually. This is going to be sine of x is equal to, I subtract 1 and divide by 2. And this one I just need to add 1. So this is negative, so remember you have to use your forecast. I need to get both answers. When is sine equal to 1/2? On your chart it's pi 6, so I can write pi 6 twice. However, since I need my answers to be where sine is negative, so I look at my forecast, and sine is negative in quadrants 3 and 4. My two answers are going to be 7 pi 6 and 11 pi 6. And as a last step, you're going to add 2 pi n. When is sine equal to 1? That happens only at pi halves. At 3 pi halves, I know there's usually two answers, but 3 pi halves, sine is equal to, sine of 3 pi halves is equal to negative 1. So this is not going to be one of our answers. But I still need to add my 2 pi n. Because every time, so here's pi halves, every time I go around 2 pi, I land in that same spot, and it'll have the same answers. And that's the answer to number 5. Number 6. Now, I can't factor here because this is a sine and this is a cosine. That would be like trying to factor this, which of course you can't do. But in algebra, you would be stuck. In pre-calc, we've been practicing changing our identities. Remember, you can never change a sine to a cosine or a cosine to a sine, but you can change a sine squared. So I'm going to use the identity sine squared theta plus cosine squared theta is equal to 1. So sine squared theta is equal to 1 minus cosine squared theta by subtracting cosine squared theta from both sides. So 1 minus cosine squared theta. And I put that little note in there. Use the trig to rewrite it. Of course, you're still not going to do anything just like this. So let's make it nice. Oops, it does need to be an x, even though my rule was with theta, I do want an x in this particular problem. And you may think that this is funny, but I'm actually going to move everything to the other side. I really think factoring is easier when your square term or your first term is positive. That's positive. This is negative. And 2 minus 3 is negative 1, but when I move it to the other side, it'll be positive 1. Remember that if you ever have trouble factoring, factor this and then go back and factor your trig problem. So a 2x squared has to be 2x and x, and a 1 has to be 1 and 1. And if you make them both negative, you'll have negative 1x and negative 2x, which will give you that inner that you want. So 0 is equal to 2 cosine of x minus 1 times cosine of x minus 1. I'm going to solve them separately. I'm going to set them both equal to 0 because one of those two factors has to be equal to 0. And I get cosine of x is equal to 1, or cosine of x is equal to 1/2. Add the 1, divide by the 2. When is cosine equal to 1/2? Remember, there's always going to be two answers. I look on my chart, and I see that it happens at pi thirds. So I can write pi thirds twice, but I need to know which of the pi thirds. There's pi thirds. There's 2 pi thirds. It's just a reference angle. there's 4 pi thirds, and there's 5 pi thirds. So you're always going to be using your forecast. I know I keep saying the same thing over and over again. I hope you're starting to do these on your own instead of listening to me drone on. But it's positive, so I'm going to want quadrants 1 and 4. So my two answers are going to be pi thirds and 5 pi thirds. Cosine's period is 2 pi, so I'm going to add 2 pi n. When is cosine equal to 1? Cosine starts off at 1. So when x is equal to 0. So it seems a little funny to write 0 plus 2 pi n, but some people really prefer it. But it doesn't need to be written. So your answers can just be 2 pi n, 5 pi thirds plus 2 pi n, and pi thirds plus 2 pi n. You're not required to write the 0 plus if you don't want to. But if it helps you think it through, then you can do that. Okay, let's go ahead and do the next one, number 7. I would put this as another most missed problem on a quiz or a test. People really think that there's a relationship there, but there's not. The relationship is only true with squares. So what am I going to do? I'm going to square both sides. However, when I square both sides, do not distribute the square. Do not distribute the square. Meaning, if you thought for a minute that this was cosine squared plus 1 is equal to sine squared x, first of all, we know from this that that's not even true. But then you forgot to multiply it all the way out. So usually my advice to students is to write it out twice. So it's cosine squared plus 2 cosine of x plus 1 is equal to sine squared x. And just for a second, you might think, how did that help me? It does, because now that it's a sine squared, I can change it to a cosine. Remember that sine squared is the same as 1 minus cosine squared x. I have a square in my problem, so I set it equal to 0 in factor. I'm going to bring this one over, which would make 2 cosine squared x. I don't have any cosines over here, so this stays the same. And I'm going to bring the 1 over, but if I subtract 1 from both sides, I get 0. So on the outside chance that somebody gets this far, they thought to square both sides, they didn't accidentally distribute the square, they correctly changed sine squared. This is already a hard problem. But then on top of that, people just automatically go like this and they get stuck. What are they forgetting? They're forgetting factor out first. I know math has so much to remember. Factor out first. So I can take out a 2 and a cosine x. And when I do that, I'm left with a cosine of x and a 1. So either 2 is equal to 0, that's one of my factors, and 2 is not equal to 0, or cosine of x is equal to 0, or cosine of x plus 1 is equal to 0. So when is cosine equal to 0? That happens at pi halves and at 3 pi halves. And when is cosine equal to -1? That happens just at pi. Now before, I did leave room for it, but before I add plus 2 pi n, this one does say they only want the answer in this interval. So at pi halves, if I add 2 pi, I will have gone past my interval. And same thing with the other ones. Now, as if this problem already wasn't hard enough for all the reasons we've been saying, on top of that, you have to look for extraneous solutions. So we talked about this recently, how when you square both sides of something, if you just have x is equal to 1 and you square both sides, you're suddenly going to have x squared is equal to 1, which when you set it equal to 0 and factor is suddenly going to give you 2 answers. X is equal to plus or minus 1. But you knew that the original problem was just x is equal to 1. So we call this an extraneous solution. Squaring both sides can do that because it creates a positive and a negative possibility. So if you actually go back and check, cosine of pi halves plus 1 is equal to sine of pi halves. This is 0 plus 1 is equal to 1. This answer is good. Cosine of 3 pi halves plus 1 is equal to sine of 3 pi halves. This is 0 plus 1 is negative 1. This answer is no good. That's extraneous. And we can check the last one. Cosine of pi plus 1 is equal to sine of pi. Cosine of pi is negative 1 plus 1, and sine of pi is 0, which works. So there's only 2 answers, not 3, on a very, very challenging problem. Okay, so now we have a little bit of a new concept, and that is we're going to solve an equation with what they call multiple angle, which means that it's not just cosine of x, it's cosine of 3 something. So in this case, 3t. So first we're just going to pretend that that 3 isn't even there. So 2 cosine of 3t minus 1 is equal to 0. I'm going to add 1 to both sides. I'm going to divide by 2. I'm totally ignoring that 3t. I'm still ignoring it. When is cosine equal to 1/2? Cosine is equal to 1/2 at pi thirds. I write the answer twice, and I add my 2 pi n while I'm thinking of it. I think about my forecast, and cosine is positive in quadrants 1 and 4, so pi thirds and 5 pi thirds. Okay? When you are about to box your answer, literally about to box your answer, that's when you divide by k. All right, so this actually solved for 3t. You just figured out when 3t is the answer, but I just want t. So I'm going to divide by 3. Now, it's very difficult to divide a fraction by another number, so let's talk about that. Pi thirds divided by 3. The easiest way to divide fractions is actually a fraction by a whole nother fraction, not just a whole number. So change it to 3 over 1, and then flip it and multiply, or keep, change, flip. Either way, it's going to give you pi ninths. Got to get good at those fractions. So t is equal to pi ninths plus, and then that one is already a whole number, so you can just leave it 2 pi thirds n. And then the other one would be the same, 5 pi ninths plus 2 pi thirds n. Okay, I cannot stress enough that all the time people do the division at this step where they just found the pi thirds and the 5 pi thirds, and then they write plus 2 pi n. But it's not going to be plus 2 pi n. And I'll explain real briefly why, and it'll make more sense. But in case you don't understand the explanation, if you just do it when you're about to box your answer, literally as the very last step, then you won't have to worry about this. But think about this. If this was the equation y is equal to 2 cosine of 3t minus 1, wouldn't that change the period? The period would be 2 pi over, instead of 1, this is a 3. So it's going to finish the whole entire thing by 2 pi thirds. So for cosine, it's going to go down, up, and then back again. So when is it going to repeat? It's going to repeat every 2 pi thirds. That's its period now. So that's why that changes. Or you can just tack on the period if you're really good at finding the period. All right, we'll try one more of those, and then you'll be able to do your day 2 homework. So when do I worry about that x over 2? Not until I'm about to box my answer. So my first step is to divide both, or not to divide, to subtract 3. And then I'm going to divide by 3. I look at my reference angle. When is tangent equal to 1? at pi fourths, there's going to be 2 answers. And for tangent, we're adding the period, which is just pi n. Because tangent is -1, I'm looking in the second and fourth quadrants, because according to my forecast, that's where tangent is negative. So I want 3 pi fourths and 7 pi fourths. I'm about to box my answer. That's when I say, oh, x over 2 is equal to 3 pi fourths plus pi n. And x over 2 is equal to 7 pi fourths. I didn't actually find x. I found x over 2. So I was just about to box my answer, and that's when I've got to get rid of that 2. Or last time it was a 3. And how do I get rid of it? I multiply both sides by 2. Both times. And so my final answer is that x is equal to, so again, fractions are people's hardest thing. When you're multiplying a whole number by a fraction, it's often easier to do a fraction by a fraction. And then you can go straight across the numerator and straight across the denominator. And this one actually reduces to 3 pi halves. 3 pi halves plus 2 pi n. And then sometimes people get confused and they say, oh, I thought we only added 2 pi n for sine and cosine. This is tangent. Well, remember that this period is normally pi. It goes from negative pi halves to pi halves. But this one's going half the speed. So this one actually goes from negative pi to positive pi. It goes like that. And so it's only going to repeat every 2 pi n. And my other answer is 7 pi, not 7 pi, 14 pi. So let's go ahead and do the math again. 7 pi fourths times 2 over 1 is 14 pi fourths, which is 7 pi halves. So the other answer is 7 pi halves plus 2 pi n. Okay? And there you go. That is the end of this section. There is a third video on it, but now you can do the day 2 homework. Have a great day.